Hello everyone. Hello everyone watching on Twitch and hello everyone watching on YouTube. So what we're going to do today is we're going to continue with ziglings exercises. I do have my voice published on YouTube for the previous exercises and we're going to continue now. So I haven't been streaming or publishing any content almost for a month now. What happened is I went to travel to China. It was a very good travel. I enjoyed it very much. However, when I came back, what happened is I got sick, and partially because I was in Beijing as well, and it was very cold there. So I got sick, and till now my throat is a little bit. It feels a little bit weird. It's a little bit harder to speak, so bear with me here. However, I did enjoy my travels. It was quite fun, and besides getting sick, I had some issues at work, and all of these kind of like got down to me. So what happened is I kind of messed up my sleep schedule as well. However, it's okay. So the reason why we're learning Zeek is because I feel like I'm just an average web developer. I do have some years of experience in doing web development, so mostly JavaScript, TypeScript, and Python. I use Django at work, and I feel like I need to learn some lower level languages to actually teach me the concepts of fundamental concepts of CS, so general CS fundamentals, as well as just having something to code that is much closer to the hardware, to the laptop, to the PC as well. Right. So we're going to do that, and I suggest you, if you are watching this, to actually try yourself to learn some lower level language as well if all you do is web development, right? So yeah, just for background, like I work React and Django, like, so very simple stuff. I had like 1 hour of sleep tonight, but I had my coffee, and yeah, I guess I'm ready to go in. So let's just switch to Emacs. So in this entire month, I didn't completely waste my time. Mostly I did, but not all of it. So we already covered all of these exercises, and we left at pointers last time. So I kind of like went through this exercise again just to remember the syntax because it's been a while since I actually coded in Zig, and I went through the language references. I'm still going through it. The reference is big. There's a lot to read. There's a lot of concepts to grasp. There's a lot of things to understand, and I'm going about it slowly because it's very important, I think, for me to actually grasp the things. However, I think once we go through these exercises, that will be enough, and I'll be trying to start to build some project. I do have a bunch of ideas for the projects that I'm going to build, and but we have to go through this exercise. I feel like it's better for me and for everyone watching this as well. If I go through these exercises, I do get some skill, I have some understanding of what's going on, and yeah, we'll just try to keep it more entertaining. I also kind of went through rebranding, so for anyone subscribed to me or followed me and watched me before, we changed the name. So my name now is Coding End, and yeah, we just changed profile pictures and all that stuff. Not really important. So let's just dive in. Right. Yeah. Okay. So pointers in Zik. Okay, check this out. So we have foo and bar variable. One of them has the star. So this is my doom. This is where I'm going to be very stupid. Not that I was very smart in my previous exercises, but well. Let's see. So what is the pointer? It's a reference to a value. In this example, bar is a reference to the memory space that currently contains the value 5. Right, so we have a type declaration U8, so the star basically means that this variable is a pointer, and we reference foo here. So which means essentially, I guess, if I modify bar, I would also modify foo. And that also means, I assume, on memory, we're kind of taking up like only one space. Again, I don't know the proper terms how to express this, but like intuitively I know it's not wasting space in memory, which means that we're not declaring like two different variables, two different values on the memory. Right. Okay, so a cheat sheet given the above declaration. The type of U8 value, sure. Assigned integer. The value 5. Yep. The type of a pointer to U8 value. So when we declare bar as a pointer, we also need to specify that. So this type basically means the referenced values type, so to which value it's pointing to. So in this case, because foo is U8, we have to declare bar as U8 as well. Will it type error if I change that? Probably will. Okay, a reference to a foo, bar a pointer to the value at foo. So bar dot star, where did that came from? The value 5, referenced value at bar. Okay, so what deferencing really means, we are going to find out. I assume we are just going to get the value of, that's how we get the value of 5 from foo. Okay, so we'll see why pointers are useful in a moment. For now, see if you, okay, yeah, it makes sense. So if I print out the bar now, I believe it will just show me the memory address at which foo is located. So this dot star syntax, I guess, is the way for me to actually get the underlying value of, yeah, value of foo. Okay, so now num2 is undefined, so we just want num2 to point to, please make num2 equal 5 using num1 pointer equal 5. Okay, so in this case we need to do it this way. Right, that's an, I don't think I've seen the syntax like this before. Interesting. Okay, let's just compile it, and to compile it we need to use our zig and build, right? Okay. Oof, it's been really a while since I've done it. Right, so yeah, so far it makes sense. Let's just go to another exercise. Okay, so it's important to note, okay, we're here, that variable pointers and constant pointers are different types. Okay, so given var foo u85, const bar u85, then reference foo is a type of const pointer u8, and reference bar is of type pointer const u8. Alright, why? An interesting question. Okay, you can always make a const pointer to a mutable value, but you cannot make a var pointer to a mutable value. You can always make a const pointer to a mutable value, but you cannot make, okay, so what they're saying is that if something is a var, I can, right, so let's say if we have var something, so let's say var foo, and then it's u8 5, we can do this. So that's what it's saying. Wait, can we do this? Const u8 equals reference. That's not the right key. Well, my editor is not complaining, so I guess we can do that. And what if we change this to var? It's still not complaining. What if we change this to to const. Okay, I really think it just won't complain about this, so we actually need to compile some code. Right. So fix this. Okay, so we need to specify const here. But what I'm going to do first is I'm going to try to change this to var, and then I'm going to change this to const, and let's just see what happens. I do believe it will just work. Okay, but what if we now change this back to const but change this to var? Right, and then we compile it. Okay, we need to supply the argument to compile the same exercise, which was what again? 40. Local variable is never mutated. So that's what it's complaining about. I can just do this, I guess. Okay, expected. Oh yeah, I can do that. Can I like just assign it again here, just to make compiler happy? Okay, it works. Wait, why it works? Wait, you can always make a const pointer to a mutable value, but you cannot make a var pointer to an immutable value. Oh yeah, because oh wait, so that means that I can do this. Right. Yeah, so I can, yeah, if I use the pointer and I specify it as a const and it points to the var, it's fine. But if I try to do it to a const, so if I make this a const, then it will fail. My nose. I'm about to sneeze. That will be very loud. So let's not do that. Alright, so let's just, where were we? Like, let's just roll it back to const. Yep, so this is fine, right? Yeah, okay. So let's just continue then. That makes sense. Is there a reason not to use? Then in that case I can always just point to the const, specify the type. I mean, I guess the syntax will be a bit too verbose, so that's the reason. Or I assume there might be some memory or performance implications by doing one versus another, which I don't know of. But I guess it's fine. Yeah, we just know when to use what. We can figure that out later, the rest of the things. Yep. So the tricky part is that pointers mutability, var versus const, refers to the ability to change what the pointer points to, not the ability to change the value at the location. Right. So const locked u85, const unlocked u810. We have two variables pointing to the locked pointers, yeah, to the locked. So both p1 and p2 point to the constant value which cannot change. However, p2 can be changed to a point to something else and p1 cannot. Right, so because it's a const, I just can't change it, right? It makes sense. But because this one is a var, which p2 is a var, I can just change it to, yeah, change it the location where it points to. So for example, from this locked, I guess I can just change it to unlocked, right? So const p3, p4, p5, p6, unlocked, 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 unlocked. Okay, wow, we have variations here. So we have const var with normal pointers and then const var with const pointers to unlocked. All of them going to unlocked, which is var. Okay, so now let's see what happens. So here p3 and p4 can both be used to change the value they point to, but p3 cannot point at anything else. But p3 cannot point at anything else. Why p3 cannot point at anything else? Because it's a const. Right. What's interesting is that P5 and P6 act like P1 and P2, but point to the value at unlocked. This is what we mean when we say we can make a constant reference to any value. Right, yeah, we know that. Okay, so what it's saying is that I cannot change, in this case, because it's a const, I cannot change unlocked to locked, for example, but I can change the value that unlocked holds, which means I can change this 10. But I cannot change the actual pointer, like to what it points to, the reference, right? Because it's a constant, right? I guess it makes sense. It's kind of similar to something that sometimes happens in JavaScript where you will have like constant variable with some object. You cannot change the object itself. Like you cannot change that constant variable to, for example, to string now. But what you can do is you can change the items in that object. I believe that's correct, yeah. So it's a little bit similar to that. Interesting, what's the reason? I mean, I guess it makes sense because when you think about it, like constant and variable, like it's about what the variable, that specific variable holds. And since it holds the reference, you might as well use that reference the way you see fit. So in, for example, changing the value that that reference holds. I guess it makes sense. Right. So please define a pointer p so that it can point to either foo or bar and change the value it points to. So in this case, then it would be var. Yeah. And this should be a pointer to U8. Okay, so P can be changed to foo, that's right. Oh, so we dereference it and that's how we modify the value. Okay, we were not shown this before. That's an interesting syntax, but I think it's quite clear, to be honest. It's not bad. Right. No. Let's see. Okay. So yeah, that should just work. Yeah, it did work. Okay, good. And now we are at exercise 42. What is happening here? So now let's use pointers to do something we haven't been able to do before. Pass a value by reference to a function. Alright. Why would we wish to pass a pointer to an integer variable rather than integer value itself? Because then we're allowed to change the value of the variable. Alright. Pass by reference when you want to change the pointer to value, otherwise pass the value. That's a good rule to go by. There is also a lot of like memory and performance implications because, like, for example, when you have a huge array of some data and then you are passing it to the function to do some manipulations with it, if you have to create a copy of that function, which means like if you have to pass it as another value, so you have your old big array value and then you have a new big array value inside that function, that becomes a little bit of troublesome in terms of memory and performance as well. But in this case it's better, right? Because you are only declaring, like, you only have that one chunk of an array in your memory and then you can use that function to modify it. Yeah, I guess that makes sense. So that's convenient. So let's pass the num reference to our function and print it. So make 5, which is here. Right, so now something interesting. Let's pass a reference to a specific array value. What would this do? we are referencing this. Why? Okay, so we are referencing an array itself. Huh. Am I supposed to? Right, so this should be var. Oh no, this shouldn't be var, so this should be this then. Because that's how we modify a pointer. We dereference it and modify it, mutate it. So in this case, we are pointing to the specific index of an array, which is here. And then we dereference it and modify it. Right, so if we pass the entire thing this way, then we would have to dereference it and then, right, would have to deal with the array first. Okay. Oh, what was happening? Just want to. This is interesting. What's happening to my. Yeah, did I just use. Yeah, just wrong buttons. I apologize for that. Let's just try to compile it. Okay, yeah, very good. Okay, so now we are at exercise 43. As with integers, you can pass a pointer to a struct when you will wish to modify that struct. The pointers are also useful when you need to store a reference to a struct, a link to it. So we have a vertex x, y, z, u32. Then we instantiate that struct. And then we have a reference to this. Yeah, we have a pointer to v1, which is this vertex. Note that you don't need to dereference pv pointer to access the struct's fields. You can write functions that take pointers to structs as arguments. This function modifies the struct v. Right. Why is this a thing? Like, as in, is this something to do with just the language syntax and the way author decided to achieve this? Or is it something to do with with the actual struct implementation? What's the difference? So what I want to say is there something technical about struct that allows you to do so, and hence it's done this way? Or is it just a syntax difference? Right. Well, we won't get that explanation, so I guess let's just move on for now. Right, so encode them like so. This makes sense. Let's revisit our RPG example and make print character function that takes a character by reference and prints it, and prints a linked mentor character if there is one. You can provide default values. Okay. I don't need to use here. I need to use question here to allow for no value. So it's a pointer to character that is null by default, and to allow nulls we question mark it. Will this error out? Well, it probably will if we compile it. Huh, interesting. Why? I'm just wondering why. Yeah, the LSP is quite sad. Doesn't tell that much. Welcome to compile driven development. Let's go. Let's go. Right. Fix me. Please pass glorp to print character. So print character, as we can see here, accepts a pointer to a character. So we need to have a reference of glorp. Now, parameter is a pointer to a character struct. Yeah, sure. Here is something you haven't seen before. When switching an enum, you don't have to write the full enum name. Zig understands that .wizard means class .wizard when we switch on a class enum value. So wait, where is this class coming from? Okay, so it's this class. So it's an enum, and we can, well, it's saying that we can omit this part. How we were doing it before? Whoops. I do have a bunch of alarms set up. Yeah, this is what it means that this is what it means when you mess up your sleep schedule. I have like 15 different alarms set up just not to miss my stream, right? Excuse me. Right, so switch C class. We are full enum name. Yeah, it kind of. Alright, so what it means is that we don't have to do this. Okay, yeah, it's clear. Because yeah, we are checking against, we're comparing if elsing between all of these enums and the actual values. Okay, and then we print checking an optional value and capturing it will be explained later. These pairs with a question mark mentioned above. So we check if C mentor, we get that mentor, and then we print that mentor. But mentor can be null, right? So wait, let me just go back here. I wonder if the compiler will tell me that I do not check for null values. So like here, if I do not have this if statement, I believe compiler will tell me. I hope it will. Instead of guessing, I'm going to do this, and we're going to try. It will probably error out on the fact that we'll not output everything. Yeah, right. Wait. The expected mentor to print something, but do we really? Oh, we did assign something to mentor. The mighty coder. What if we don't assign anything? Yeah, it tells me that the mighty coder is unused, but that's not relevant. Yeah, let's just leave it there, I guess. It might not actually tell us if there's something wrong. It's not Rust. Right. Okay. where we are at now. So let me just quickly go back here. Elephants walking along the trails are holding hands by holding tails. From Holding Hands by Lenore M. Link. Alright. I guess we are on our own now. Please add elephant B here. What do you mean by elephant B? Alright, yeah, so we need elephant B. Elephants walking along trails are holding hands by holding. Wait, what's the compiler? Use of undeclared identifier elephant B. Alright, yeah, sure. So we want elephant B, and we don't have to declare the type. It can inherit it. Not really these, and we are following the same example, so it will be letter B. Yeah, so wait, what happened here? That's not what I want to press. Okay. Link the elephant so that each tail points to the next elephant. They make a circle. Are we creating? Yeah, we're almost creating linked list here. So ABC, right? So we have. Okay, we need to have elephant, and tail is the pointer to an elephant, which makes sense. So we want to reference elephant. If I can type this, C. Right. Now we are visiting these elephants now. We are lead coding live on stream with Zig. Let's go. I wish every single lead code problem was explained this way. Elephants. Oh, cute. This function visits all elephants once, starting with the first elephant and following the tails to the next elephant. If we did not mark the elephants as visited by setting visit true, then this would loop infinitely. So we have first elephant, which we assign here, and we're checking if it's not visited. Then we print out, we change it to visited, and then we change E to E-tail, so to the next one. And then we're going through all of them and just mark them all as visited. It should iterate only 3 times then, so which means ABC in our case. Let's try. And this is what happened. Nice. We are jumping to the next topic. Optionals. Right. Let's go. Sometimes you know that variable might hold a value or it might not. Zig has a neat way of expressing this idea called optionals. An optional type just has a question mark like this. Okay, I believe previous or the stream before we were actually wondering how to declare optional values. Right. I think what we were doing back then, we were just kind of like setting those as undefined. Now I wonder, yeah, undefined is not null. They are different, yeah, so it's completely different concept. Because undefined means that you do not have, there is no intention, I would say, or opposite. So we could say that null is more intentionally null. Like there might be a reason why it's null. So for example, if we call some other API, the API might just not return any data. So the variable might be null. But undefined means that we want, for example, we kind of want to declare that variable, but we do not have a value for it yet. So it is undefined. It's different concept. Can be used interchangeably, although wrongly, but it can, right? Kind of. I believe depending on the language, the behavior between null and undefined are different. It is definitely different in JavaScript, and I don't think it is different in Python, to be honest. I'm not really sure how to declare undefined in Python, but I think it's like just none, which is like the same as null, right? It's not really the same, so I guess there must be a way to declare undefined variable in Python as well. I just don't know it. Not that I really have a reason to do so. When you think about it, no, actually there might be reasons to declare like undefined when, for example, like just from the basic prototyping standpoint, you might want to declare some variables, but you might not have a value for them yet. Right. Hey, that's a good question. You know what? I'm genuinely curious to ask AI about this, and we are going to do that. Okay, wait, we need to zoom in here a little bit. That's a bit. And one more. Yeah, that works. So why would some languages allow to declare variables and make them undefined? Is there a reason to use undefined instead of null? Practical reasons, I guess. Like, let's just specify that. This is a great question about programming language design. Yay! I got pat on the back from AI. Memory efficiency, error detection. Yeah, that typically means this file has not been assigned, yet this file intentionally was absent for functions that don't explicitly return anything. Right, so I get this part. Having variables initially undefined means no memory is allocated until an actual value is assigned. Yeah, okay, that all makes sense. The reason what I'm asking is, I guess still, yeah, it's probably something to do with like a planning or something where you would have some bunch of variables defined, but you do not have a value for them yet. Hence, you define them for later use or for maybe because of the code style. So, for example, you would have your variables defined at the top or something, but you do not have the values yet. So it makes sense in this way. And it in this case it like absolutely makes sense to use these over nulls. Yeah, I should think about it more. I tried to remember if there was any case where I had to use it, and I remember there was, and not that far long ago, maybe a few months ago. But now I do not remember that scenario, so let's just ignore it, I guess. Right. Let's just start a new chat here. I can do that later. Okay, go back. Yeah. So now foo can store u32 integer or null. A value storing the cosmic horror of value not existing. A value storing the cosmic horror of a value not existing. You know what, guys? I'm sorry, but this is going to Twitter. That being said, the Twitter is down. Is it back up again? Can I tweet something? I cannot. Well, that's unfortunate. Let me just try and see if the post request gets through. We continue. The Twitter is having a hard time surviving. Foo equals null. If foo equals null, begins screaming. What the heck is this? I like this. My god, what's happening here? Before we can use the optional value as the non-null type, either to integer in this case, we need to guarantee that it isn't null. One way to do this is to threaten it with the or else statement. Wow, that's a new syntax. Okay, that's cool. Or else. So it's like kind of like ternary operation, right? Here bool will either equal to the u32 integer value stored in foo, or it will equal to 2 if foo was null. Yeah. Please threaten the result so that the answer is either the integer value from deep thought or the number 42. Please threaten the result. Or the number, wait, what's the result? Okay, so deep thought is here. You know what, I think I just got the joke. So your threatening is like, I do this, or else, or more, so you shouldn't be null, or else I'm going to come for you. Or else. And what do we do here? 42. Right. That's a weird keyword. Yeah, so this should be fine. Okay, it seems deep top output has declined in quality, but we'll leave this as is. Sorry, deep thought. You know what? We kind of have like this funny moment where I noticed some like deep something used by ziglings, which like reminds me a lot about DeepSeek, and it's all like kind of like fits into AI reference, and I feel weird now. Are we living some conspiracy theory? There was something that I tweeted about this as well. Well, doesn't matter. So yeah, because this is like an actual situation with DeepSeek right now, so it's just like you can just do it this way. Yeah, that will be the same thing, right? No offense to DeepSeek, they do have a good models, but well, their API was down for like 2 weeks at least, right? So yeah, okay, let's keep it on the topic. So blast from the past. Optionals are a lot like error union types, which can either hold a value or an error. Likewise, the or else statement is like the cache statement used to unwrap a value or supply default value. Yeah, right. So we had this syntax, yeah. So if there is a potential for error, so for example, you assign a value returned by a function to a variable, but it can also return an error, you would kind of have to check. So the catch is one way of doing that. Simple way of doing that, I guess. Yeah. Let's compile it. Yeah, and we are good. Okay, expected colon after statement. Okay, we have question. So what's happening here? Let me get some water first. You know what? I realize you guys might not see the full errors like this output, but oof, what was the sound? I'm sorry, but I believe it's not a big deal. Yeah, because the most important stuff is happening here. guess I can fix that later. It's fine. It's not a big deal. Right. So what we're doing? Okay. So now that we have optional types, we can apply them to structs. Uh-oh. Why I feel like it's not going to be simple. The last time we checked in with our elephants, we had to link all three of them together in a circle so that the last tail linked to the first elephant. This is because we had no concept of a tail that didn't point to another elephant. We also introduced the handy dot question shortcut. Const full bar dot question is the same as conf or else unreachable. Check out where we use the shortcut below to change the control flow based on the optional value exists. Now let's make elephant tail optional. Tail needs something. Link the elephant so that each tail points to the next. Link elephants will stop the program if you try and link an elephant that doesn't exist. Uncomment and see what happens. Right, so we can delete this and delete this. Yeah, just assign. Oops. What did I just do? Okay, never mind. So missing elephant. Okay, we need to see what link elephants does. So if E1 and E2 are valid pointers to elephants, this function links the elephant so that E1 tail points to E2. So A, B, B, C, but C will be not pointing to anything. Right. You know what I'm confused about is how can you... Wait, let me just double check that I didn't like accidentally did anything weird. No, I didn't. Right, so like... Oh yeah, okay, I did. Okay, it was null here. Oh, I got confused. How did I delete that now? What did I press? Welcome to Emacs. Right, so that's a missing elephant, and we are trying to link elephant C with this missing elephant with null. So this should... What? Okay, wait, save file, yes, correct. Okay, still complains about question marks. Let's see. Okay, we should stop once we encounter a tail that does not point to another element. What can we put here to make this happen? We want something similar to what does, but instead of ending the program, we want to exit the loop. Right. Okay, the link elephants would probably not fail because it's kinda like checking if there is an elephant. Yeah, if the tail... Yeah, if there is an elephant, then the tail is here. Wait, but can we... Yeah, this is still autocomplete, yeah. And it will link it, basically. It will assign it only if there is something. So because missing elephant here is null, this will not fail. But this will fail, right. Wait, why it will fail? Because we assign E to E dot tail. Okay, nowhere here we are checking that the E is null. And because we do not do that, the E visited might not change in some cases. And because we do not change E visited, E dot visited, I mean, what happens is that we're creating infinite loop. And infinite loops are not good. So, can I do this? I wonder now. Or else break. tails need something. The type. Yeah, so this should be question mark. Terminate unexpectedly. Yeah, this. Okay, wait, this question mark, sure. Like, elephants will stop the program if you try to link an elephant that does exist, uncomment, and see what happens. If E1 are valid points to the function, the events to the points to be. Are valid pointers to dysfunction links. Right, but this is what's failing right now, right? It's not that last part. Uh-huh. Why? And now we're confusing. It's getting confusing. Yeah, we do. So it shouldn't assign it. Why does it just stops? Let's think a little bit. So, do we want this? Wow. No, what? Okay, wait. Because tail can be technically a null if I'm not mistaken. Right. So then we can assign something that is null. So in this case, the missing elephant is null, so we just assign. But why does this just like terminates the program without any reason? Oops. It doesn't tell me, it doesn't even tell me what's the issue, right? It didn't. Let me try again. Yes, it just terminates unexpectedly. Why? Is it because essentially what dot question mark does is just checks if there is something, but there is no else statement. So because I do not have an alternative value to assign to, it just errors out, and we do not have explanation for that. We'll stop the program. Yeah, I do not. But I guess, yeah, let's leave with what I said just now. So because we don't have an alternative value of assigning it, and it will not just assign null, so it will just fail, which I guess is a good behavior. So yeah, okay, we can compile it now. Let's continue. Methods. Okay, methods. Are we talking about something to have inside the struct? Oh my god, that's a lot of read. You know what, guys? I have to take more frequent breaks. Okay, right. Help. Evil alien creatures have hidden eggs all over the earth and they are starting to hatch. Before you jump into the battle, you will need to know three things. You can attach functions to structs and other type definitions. So have struct here with a function. Oh, what? Okay. A function that is a member of a struct is namespaced within that struct and is called by specifying the namespace and then using the dot syntax. Okay. The neat features of these functions is that their first argument is an instance of a struct or a pointer to one, then we can use the instance as the namespace instead of the type. If their first argument is an instance of a struct or a pointer to one, then we can use the instance as a namespace instead of the type. So it's equivalent to bar A. Yeah. Okay, so if we basically can default supply the first argument as the struct itself. So these bar, const bar, pointer, or the yep, okay, that makes sense. Notice that the name of the parameter doesn't matter. Some use self, others use lowercase version of the type name, but feel free to use whatever is the most appropriate. Okay, you are armed. Now please zap the alien structs until they're all gone, or the earth will be doomed. Look at this hideous alien struct. Know your enemy. We hate this method. Okay, alright, we do hate this method. So hatch alien returns an alien, so it returns itself with higher strength. Okay, your trusted weapon zap those aliens. Okay, heat ray, we love this method. Zap accepts itself and the alien, and then alien health minus if self damage is higher alien health, then we assign it to alien health, else assigned to the self damage. So if the damage is higher, right, so we either kill it completely or we just do the damage. Okay, that makes sense. Look at all these aliens of various strengths. Hatch 2, 1, 3, 5, 3. Okay. Aliens alive, aliens at length. Heat ray. Damage 7 will be given a heat ray weapon. We will keep checking see if we killed all the aliens yet. If aliens alive, look through every alien by reference. Makes a pointer to capture value. Oh. Okay, so we can iterate over the reference and we are getting the pointer. A pointer to an alien. So here we want to use that heat array, zap, and zap accepts alien or self. So we can wait, can we do this? I forget. The alien would be alien is accepted by reference, hence we can just do this. Alien. Or that's probably not the syntax, yeah, so we won't do this. Alright. Wow, I actually didn't realize, okay, we can't do this. What's there they're saying? Expected expression, okay, so we probably can do this. Okay, alright. If the alien's health is still above 0, it's still alive. Okay. Alright. Unable to resolve comp time value. Why? Types must be comp time known. Should we do it this way? Yes, but loop through every alien by reference. Star makes a pointer to capture value. Now why? Because it says here, right? So it's just star alien. But passing star alien here is not what we want. What will happen if we do this? Okay, so we need to recompile this specific exercise, so it will 47. Expected found. Expected pointer to an alien found alien. Which means we can do this. Unable to resolve at comp time. Right, so why this is a bit confusing. Okay, so I think we are just going to ask AI about this because I am genuinely confused. This is the best way to use AI. So I am a bit confused in this zig code. Why I can't? Okay. When I pass, let's say inside for loop, pass alien 2.zap method as a get error. Can you tell me why? Make a pointer to a pointer. Yeah, because okay, so it's simply the fact that we are iterating over the reference to aliens, we get the pointer out of it. And because we get the pointer out of it, we can just pass it directly. But now the question is why this doesn't work. Right, because supposedly this is a pointer. So then let's just ask, then why this does not work as well? Alien is a value, and alien is not a pointer. Let me explain here. Alien is a pointer, creates an array of pointers to the elements, creates a pointer to each element of that array. Here alien is just value to alien, still creates an array of pointers, by then without it gives you the value that the pointer points to. Right, so essentially it's just a memory address. Then it will be, it won't be even this thing. Okay, guess that makes sense. I'm still a little bit confused, but it's fine. That's alright. We can move on. This is one of the things that the more I do it, the more I encounter different types of doing the same thing. I will kind of start to understand it more, so it's okay to just skip ahead. No, sometimes there is no point to like keep bashing your head against the problem without actually making any progress. It's better to just move on and just try more different variations of applying the same concept. With the practice, there will be one moment where it starts to click. So that's important. Very important, especially like when you're learning new stuff, because it's better to just go through with some understanding than not understanding because you give up, right? So yeah, the progress is important here. So let's just move on. Right. Now that we've seen how methods work, let's see if we can help our elephants out a bit more. Some elephant methods. Okay, so we have tail and visited. Okay, we have now get tail. Yeah, this this is generally a lead code problem disguised as elephants. So we have this means or else unreachable. Okay, so new elephant methods. Oh yeah, okay, so one of the like things that we were well that I was confused with before when the program was exiting unexpectedly is because it was reaching the unreachable statement. Yeah, makes sense. Okay, so get tail, which accepts self and returns the tail. Has tail is basically checking if tail is not null. Visit just change the visited to true, and print prints elephant letter and visited. So v or nothing. So we then print the letter and we print the v. So v or nothing. So we have A, B, C. This links elephants so that each tail points to each tail points to the next. So A points to B, B points to C. Visit elephants. This function visits all the elephants once, starting with the first elephant, following the tails to the next elephant. Print visit. This gets the next elephants or stops. Which method do we want here? So we are checking if it has tail. So if it has tail, then we assign. Wait, do we want the method? Alright. Okay, we do have a get tail method, so we just probably use that. And here, yeah, because tail might be null. Hence, what we want to do is what we want to do here is to just get tail, because this method already defines the dot question mark notation, so or else unreachable, so basically checks for the nulls. So what's happening here? Zig enums can also have methods. This comment originally asked if anyone could find instances of enum methods in the wild. The first 5 pull requests were accepted and here they are. Found in the Zig source. I found one. Let's check this out. Let's check the first one. Enum. Clean support. I wonder what would be the good case of using methods on enums. So let me just zoom in a little bit. One more, I think. Yeah, that's better. I would imagine some sort of utility functions. So in this case, clang support dev file. So we're checking if extension is one of these. Yeah, so some sort of utility functions to simplify the logic, because yeah, this method would be otherwise an outside of this enum. So it kind of depends, I guess, like in this case, whether you want this method to be a part of your like data type declaration or outside of it. Guess it makes sense. I'm not really sure how. I don't have a strong opinion, I would say, about having methods in enums. Unfortunately, I don't have. Oh, there is a bunch. Wait, no, this is already outside of. Yeah, this is already outside of it. Right. All good, all good. Okay. Love this language so far. Spencer C. Dixon. Right. Let's continue. So this should compile. And it does. And we are at the quiz. So let me just quickly check where we are at now. So we started at pointers, we went through optionals, and we went through methods. So we are having later slices, many pointers, and unions before we hit quiz 7. Yeah. So it's already getting a bit late. I'm streaming already for 2 hours, and surprisingly at the end of my stream my bitrate is very stable. We are going to end the stream after I finish this quiz, and the next stream, yeah, most probably we will attempt to go a little bit further and complete all of these. So that will be 25 exercises, but I'm not sure. Let's see. It might be a little bit too much, a little bit too enthusiastic, too ambitious, because I can't be doing too many of these in one sitting. I will just simply not grasp the concepts. I will just not learn anything. However, I do also want to complete it faster and just try to apply all of the things that we learned into practice, because in the worst case, if I forget something while I'm working on some project and I need to get back and reference, I can just Google, try to search Zig reference, or I can always just come back to these exercises. So I think it's okay, it's alright. But for now, I think let's complete at 51, I guess. So let's do a couple more here, right? Let me see what are the slices about. Yeah, but I probably don't want to touch slices yet. So let's do quiz 6 and then let's see. Right. So trunks and tails are handy things. Now that we have tails all figured out, can you implement trunks? Elephant tail methods, your elephant trunk methods go here. So trunk would be the front. Now we have print, visit. Right, so we don't touch this. Okay, we just need this method. So that would be public function get trunk. Oops, get trunk, and then we have self. So let's just continue this standard of using self instead of this or anything else. So we have elephant, and then we are returning the pointer to an elephant. So which would be returning self.trunk, and it can be null as well. So wait, did it just elephant? Emacs. Okay, elephant. Okay, yeah, we want to do this, and then we want to have a method to check if there is a trunk. So has trunk, and then we want self pointer to itself, and then returning pointer to itself as well, which would return check self dot tail, not tail, self dot trunk, and we are checking for being null, so not null, then it has trunk. Okay, alright, now let's see. So we are also link the trunks. So this function visits all twice tails to trunks, right? So we check the tails, now we follow the trunks. Get trunk. Okay, so it already has these methods implemented. I believe that's how I named them as well. So this should compile now. We forget the colon here. Okay, semicolon. If E has trunk. Wait. Right, so this should not return the pointer, this should run the boolean. Compiler driven development. Yeah, let's go. Okay, very good now. So CBA. Okay, alright. Yeah, that was simple. Okay. Guys, you know what? I am going to end the stream here. I think it's enough. I think we learned a bunch of things. So let me just open this up. We covered pointers, we covered optional values, so question marks. We covered methods that we can attach to structs and enums. We learned how to dereference and reference values. We learned or else, or in other words, how to threaten the null values. And I believe what we're going to learn next is about different type of undefined values, so no values, and different type of actual values. So I believe that would be the case. There is like a little bit too much to read and for me to continue. I'm a little bit tired now. As I said, just slept 1 hour. We were strong at the beginning of the stream, but now I feel a little bit of tired. And yeah, thank you everyone for watching. Thank you everyone for watching this on YouTube. I hope this content was enjoyable. I'm doing my best. Let me know if you have any feedback for me. How can I improve? What I can do better? And yeah, thank you so much for joining. Thank you so much for watching. Bye bye.